Here is our last section for Chapter 12. We're putting it all together here with the sequences and series that we've learned so far for both arithmetic and geometric. Again, I just want to review the terms. Sequence is a set of terms that follows a pattern, and a term is an actual value in a sequence. So let's, for instance, say that we have to write the first 6 terms according to the rule a sub n equals n plus 4. So we need to know what is the first term, what is the second term, and so on. First term means you're going to put a 1 right there. 1 plus 4 is 5. Second term, you're putting in a 2 right there. 2 plus 4, 6. So each time we're just going up by 1. So the next term is 7. So you're going to have 5, 6, 7, 8, 9, 10 for your terms. Second question here, write the rule or the explicit formula for negative 2, 6, negative 18, and 54. Now remember, in order to decide what kind of rule we need, we have to decide is it arithmetic or geometric, and to do that we have to go backwards and decide if we should subtract and get the same thing or if we divide. 6 divided by negative 2 is negative 3. Negative 18 divided by 6 is negative 3. This one looks like it's going to be geometric because every time we divide, we get the same common ratio. So this one is geometric. Common ratio is negative 3. Our explicit formula will be a sub n equals, if you remember the rule, first term, common ratio n minus 1. So we have for our first term negative 2. Our common ratio is negative 3 raised to the n minus 1. There's our explicit formula. Remember, in a series, we're adding the terms of a sequence together. For this particular example, we want to write the rule, find the nth value, and then use summation notation to find the sum. So if we just double check here, if we subtract backwards, 50 minus 25, 75 minus 50, we get the same common difference each time. So this one is arithmetic. Our common difference is 25. And remember, with an arithmetic sequence, we have to go backwards and see what term we actually started with. So if I follow the rule, instead of going up by 25, we'll go backwards 25. This thing started at 0. So our our a sub 0 term is 0. Our formula, a sub n equals dn plus a sub 0. Common difference is 25. And we started this at 0. So it's just a sub n equals 25n. So that answers the first part, write the rule. Now we need to find the value of the nth term. We know the actual answer is 250, but we want to know which term is that. This is a sub 1, this is a sub 2, this is a sub 3. Which subscript, a sub what, gives us 250 for an answer? What we're going to do is go backwards. We're going to use our explicit formula, and we know that the answer is 250. What n number gets us there? 250 equals 25 times n. We're just going to go backwards, do our divide by 25, and we get n equals 10. So this is really a sub 10. That's the nth value. Now we need to do summation notation. Summation notation is your sigma. We're going to start with the first term, and we have to add up to how many terms. That's the reason we needed to find this. We are adding the first 10 terms according to the rule 25n. This is the appropriate way to write sigma notation. We have to have a starting value, we have to have a stopping value, which term are we going to stop with, and we have to have the actual explicit formula. Now we solve the formula by using our arithmetic series equation. Do you remember your series equation is n, first term plus last term, divided by 2. N refers to how many terms we're going to add together. In our case, we're adding 10 terms together. A sub 1 is the value of the first term. That's this guy, 25. Plus, a sub n is the value of the last term. The last term in our sequence is 250. And then we're going to divide by 2. You can just get your calculator out. 25 plus 250, take that answer, times by 10, and divide by 2. 1375 is what you should come up with for that one. Next one. Can you write the equation for this? Which term are we on for 100? Can you write the sigma notation? And then can you find the sum? This one again is arithmetic. When I go backwards each time, I get a common difference of 5. A sub n equals dn plus a sub 0. A sub n equals 5n, and the 0 term is 0. So this is my explicit formula. Now I need to know which term has the answer of 100. I will go backwards. 100 equals 5 times n equals 20. So this is a sub 20. I can now write my summation notation. I will add from the first to the 20th term according to the explicit formula a sub n equals 5n. There's my sigma notation, and now I can find the actual sum. 20 terms, the value of the first term plus the value of the last term. First term, a sub 1, last term, a sub 20, 5 plus 100, and the whole thing divides by 2. 5 plus 100, add that, 20 divided by 2 is 10. 10 times your sum of 105 gives you 1,050. Several parts to a question like this. Write the explicit formula, which term is represented by the number 100, write the sigma notation, and then find your sum. Let's try that again, but this time we've got a geometric sequence. Go backwards, dividing. Common ratio is 6. Common ratio is 6. My geometric equation, a sub n equals first term times common ratio to the n minus 1. A sub n equals first term is 6. Common ratio is 6 raised to the n minus 1. Now for this one, we're not adding a certain number of terms because I see these dot dot dots keep going. So this is an infinite sum. So what is the sum of the infinite series according to the rule 6 times 6 raised to the n minus 1? Now if you can remember your infinite sequence and series rules, if I'm trying to get a sum for an infinite geometric sequence, I need to make sure that that common ratio value is less than 1. This common ratio is 6, which means it's greater than 1, which means this has no sum. It just keeps getting larger and larger and larger and doesn't approach a particular value. Let's try this one. 5 plus 6 plus 7 plus dot 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 plus 12. And when you look at questions like this, if you have something like this on a test, I will not accept an answer if I see something written on the side where you're doing 5 plus 6 is 11, 11 plus 7 is 18, and so on. If you're doing the actual addition by yourself, no, you will not get credit for that. You need to be able to give me an explicit formula. You need to be able to write summation notation and then use your series equations to get the answer. This one is arithmetic. My common difference is 1. Our formula will be 1n. Go backwards. This thing started at 4. So our explicit equation is a sub n equals n plus 4. I need to know which term has the value of 12. Remember, this is a sub 1, a sub 2, and so on. I need to know which n term gives me 12 for an answer. 12 equals n plus 4. 8. This is the 8th term. I need to know that number because I will be adding the first 8 terms when I write my sigma notation. So from the first term to the 8th term, according to the rule, n plus 4. My arithmetic series formula is, again, n, first term plus last term, divided by 2. I'm adding 8 terms together. The value of the first term is 5. The value of the 8th term is 12. And the whole thing divides by 2. Plug that in, 17 times your 8, divide by 2, 68. Now, on this last slide, we have some interesting types of sums. On this first one, they're asking us to add the sum of the first 34 terms according to the rule 1. Now this is actually arithmetic. It might not look it, but this is arithmetic. dn plus a sub 0. 1 represents your a sub 0 term. Your d value is 0. There is no common difference, so it represents 0. So there's nothing there. So if I think about the equation, n first term plus last term over 2, n is how many terms I'm adding together. The value of the first term, 1. The value of the last term, still 1. And now I divide by 2. 1 plus 1 is 2. 2 divided by 2 is 1. 1 times 34, 34. So think about that for a second. If I look at the numbers 1 plus 1 plus 1 plus 1 plus 1 and so on, if I do that 34 times, I'm just going to get 34 for an answer. The next one, find the sum of the first 6 numbers according to the rule n. Well, this one is also arithmetic. dn plus a sub 0, this is like 1n plus, starting number was nothing, 0. So this one is arithmetic. I'm adding 6 terms together. The value of the first term, plug in the number on the bottom. Plug in a 1. 1 times 1 is 1. Plus, plug in a 6 right there. 1 times 6 is 6. And the whole thing divides by 2. 1 plus 6 is 7. 6 times 7 is 42. 42 divided by 2 is 21. And this last one is another practice with a partial sum. Now remember, we are only adding from the 5th to the 27th term. So remember, when you do that, you subtract these values. 27 minus 5 is 22, but then add 1. There's actually 23 terms here. So when we use our rule, this rule right here, n refers to how many terms? 23 terms. The value of the first term, plug in a 5. 2 times 5 is 10. 10 plus 5 is 15. Plus the value of the last term. Now plug in a 27. 2 times 27 is 54. 54 plus 5, 59. And divide by 2. Now use your calculator. 15 plus 59 equals, times 23, divide by 2, and you should get 851. So this particular section is a combination of everything that you learned so far in sections 2, 3, and 4. Arithmetic sequence and series, geometric sequence and series, and your infinite geometric series. Okay, that's it. You can go ahead and get started on your homework for section 12.1.